people were doing over time in designing out the issues. Our mantra was, we're going to design out EHS issues as something moves through development. And this gave us the ability to see how well the chemists were doing that. And I think that's it. Yep. No, it isn't. Sorry. For some reason I went way down. So it was a single document, and again, it was something that was meant to be a living document, something that would help us identify to the chemists very quickly and effectively communicate where the issues were. So I wanted to just say how some of these things were used and answer the question, well, you've collected these metrics for years now. Are we doing any better? Are pharmaceutical processes becoming greener? And what we found, are there any correlations between all of these measures and greenness? So we looked at reaction mass efficiency versus molecular weight added. So in other words, as you build a molecule, does that impact the greenness? The answer is no, it doesn't, which is kind of surprising. If you ask a synthetic chemist, again, if I'm adding mass, isn't that going to affect it? It really doesn't. Mass intensity per chemistry transformation. Again, there was a lot of debate and discussion I've had over the years with many chemists about, well, the issue is that we're doing an extremely difficult chemical transformation. It doesn't matter. If you look at it on average, it really doesn't matter. And if you look at the life cycle impacts versus the chemical mass, again, there's not a lot of correlation. So the point in all this is that there's a lot of assumptions about what's driving greenness, and you really have to test those assumptions because they're not really true. One of the assumptions that a lot of people make is all bioprocesses are by definition better. So we wanted to test that hypothesis, and we tested it on a number of compounds because we would really want to increase the amount of renewable materials that we're using. We all know that biology is extremely selective, you know, whether it's in the R or the S isomer or whatever it happens to be. Enzyme systems are extremely selective. Typically, things can be carried out in water-based systems, which is very attractive. Many times you can avoid hazardous materials and ultimately produce less hazardous waste. So bioprocesses, again, are something that everyone intuitively thinks we should be doing. And again, do bioprocesses really have a better life cycle, and is it more sustainable? So we compared one compound, 7-ACA, which is a precursor to an antibiotic, and we looked at the chemical process for doing it and an enzymatic process. What this basically says is that the processes are basically different at, up to 7-ACA, and then they're both the same. So it's really just comparing the difference between the enzyme and the chemical process. And what you find is, in this case, the biological process was in fact, on average, a better process if you evaluate according to efficiency, environment, energy, and safety. I can tell you that it isn't always the case. In the evaluations that we did, there were a number of cases where, because the chemical synthetic method had been around and optimized, it was a better process from a green perspective. So again, looking at this from a life cycle perspective, we didn't just focus on global warming potential or carbon dioxide. We actually looked across a number of different parameters. And again, what you find there is that certain parameters will affect, differently. And we also looked at delivery devices, and we can also use it in terms of the overall company and driving metrics in the company. And this is how life cycle is used in setting targets for the company. So again, there's a variety of ways in which we've used green chemistry metrics every year. over the years. Key message is you need to use a variety of metrics. You need to look at things holistically and not a single parameter to determine whether or not something is green. I'd be happy to answer any questions you might have. Sure.
Those values that you have about, say, alcohols, such materials, reagents, solvents, are they going to stand for it? Don't you think they will be changing? Some new processes being developed?
Well, remember that the properties of the solvent don't change. So everything was ultimately based on, if it was recyclability, it's going to be based on physical chemical parameters of the solvent. If it's environmental fate and effects, you test the organism for that particular solvent. That isn't going to change, right? So it really was looking at the inherent hazard, essentially, of a particular solvent, as opposed to, which is a property of the material, and that isn't going to change. How you use the solvent in a process will change. So, for example, methanol on that list was very low. The reason methanol was low is it's typically you use aqueous workups, right, with methanol. And you can't easily extract methanol from water. You can do a steam strip and you can get methanol back, but that's highly energy intensive and most people don't do it. So that's why it ranks so low. If you're doing a synthetic process which has no water in it and no aqueous workups whatsoever, then methanol is not a bad solvent. Okay, so you really have to, in all of these evaluations, you really need to spend the time, the intellectual time, to understand what assumptions are being made in the evaluation. And one of our goals was to make all of that transparent. So again, it allowed the chemist to go in there and look at the individual properties of a solvent. I didn't show all of the guide, but if you kept peeling back the layers of the onion, we actually got to a page which was the key physical properties that were driving, the greenness evaluation. So that's the kind of thing you need to do.
Dave, your conventional versus enzyme analysis, you had all of the various parameters that you evaluated. But when you take all of that technical information, you go to the business people for the decision for implementation, there's another element, and that's cost.
Mm-hmm.
Right? So how did GSK handle the element of cost when you went from the analysis and said, here's our choice based on the technology evaluation and the decision for implementation?
We were never fortunate enough to, be able to be involved in those kinds of decisions. So everything we did was retrospective.
Oh, I got you.
Okay, it was a retrospective analysis of those things. So the chemical method for 7-ACA we hadn't been using for quite some time. And it's really just to show, the changes that were made. I would say that if you can get in early enough to do the evaluation, what we found is that they're pretty receptive. If you find something that's a particularly nasty actor that's going to increase the amount of waste that they're going to have to contend with, it makes a big difference. What I will say is that the sophistication of synthetic biology is getting to a point where I think that cost is going to become less and less an issue. When Codexis first started doing directed evolution and that kind of thing, it was very pricey, months to years of time. That's no longer the case.
So years ago, in the chemical manufacturing, the traditional chemical manufacturing sector, we talked about the cost experience curve. I don't hear that getting discussed much these days. When I think it speaks right to the point you're talking about it, maybe it's worth having that conversation because the business decision makers understand that concept and use it to influence decision making.
What I would say is that business people don't really understand technical issues at all. And at the end of the day, in all the time that I've spent in discussions with senior people in manufacturing, to be perfectly honest with you, It gets down to whether or not they trust you, and whether or not they like you. And I'm being totally honest. We would come, in developing mass productivity, it took us 6 years to prove to them that that was a measure. When we first did it, they said, get out of my office, you don't know what you're talking about, you don't understand this process, you have no clue how we run our business. So then we went and had their plant people do it. What did they do? They called us up and said, can you give us the data? I said, yeah, here's the data. So they went to them, and they got thrown out of the office. And it boils down to this constant educational process of getting people to understand that, yeah, this stuff really is true. It's based in fact. It does drive cost. Like I said, we were very rigorous in doing cost determinations, and many times it just didn't matter.
I have a question, a comment. Complexity of the chemistry and depends on how you look at it. Where you're sitting and looking at it. Okay, as an organic chemist point of view, as John Wanner mentioned, the problem is the toolbox are empty. Okay, it's not the chemist who don't want to do it. There's nothing is available in the toolbox. So for complex transformation, we don't have it. So main drive should be both academic and industrial, filling the toolbox as quickly as possible.
Right.
I don't think it's happening now. Academic, they're thinking totally in a different way. They want to publish in JACS, and this thing, you mentioned the green word in JACS, it won't get published.
Not only that, but
okay, that needs to be changed. Okay, and if you publishing more green chemistry in JACS, that will all the academic will jump into it, and that will change quickly.
what I was going to say is not only will you not be able to publish, but you have to show the comparison using the same old chemistry, right? So in JACS. So if they've used benzene 20 years ago, you've got to run it in benzene. And that's an unfortunate aspect of it, too. We've had those discussions many times with a lot of the leading organic chemists, and it's a huge problem. That's why, I think that we had talked in the roundtable, the pharmaceutical roundtable many years ago, is that doing the rounds with the editorial boards to try and get them to understand that they need to make that shift. I don't know if you've made any progress on that.
If I could just add to that, we have made progress. There were voluntary recommendations made to about 5 or 6 journals, one of which was JACS. Some of the journals have responded positively and have started to incorporate some of those recommendations. We did it first on a voluntary basis because we tried to go tell somebody this is what you got to do. It's a non-starter. The idea was that if we get a few to adopt, it'll set a precedent. People will begin to read it in the literature, and they'll begin to start asking questions. What is PMI? What is animal economy? That will raise awareness, and eventually people will start to report on that as the journals that incorporate it early get read and it becomes acceptable. Other journals hopefully will start to pile on. So I had a conversation with Pete Dunn, who was here this week, because we're still working with one of the journals who've been a little bit recalcitrant. So we're going to go back and in a partnership try to drive that forward. But your point's well taken. And I think what David just said about how long it took to influence GSK, it's just exemplary of what it takes to move the needle on these things. This takes time. So for me, success is perseverance. One more minute. You just got to keep on going.
Absolutely. Couldn't agree more. So thanks very much. Huh? Sure.
Good morning. For the next presentation, in fast life cycle analysis, can you single yes. What are the parameters taken into consideration while arriving at this?
We basically looked at 9 different categories. This was based in work that we did in the 90s through the American Institute of Chemical Engineers on sustainability metrics. So they're the classic parameters. There are a few of them that I listed here. Energy, global warming potential, photochemical ozone creation potential, mass acidification, eutrophication, so on and so forth. There's 6 of the 9 that are listed there. They're the parameters we looked at.
Okay, can you just brief us how this final score is arrived? Is it multiplication of all or something else?
It would take me a little bit of time to explain the scoring to you.
Can I catch you later?
Yeah.
Thank you.
Yeah, that'd be fun.